Good evening, children. Good evening. Good evening,
Ma'am.
online students.
Good evening, ma'am.
Good evening. Good evening. Good evening. I've shared my screen. Visible, online children?
Yes, ma'am.
Yes, ma'am.
Good. Yeah, good. So this is the first question for today's class. A conical vessel of radius 6 centimeters and height 8 centimeters is completely filled with water. A sphere is lowered into the water and its size is such that when it touches the sides, it is just immersed. What fraction of the water overflows? We'll see the question again. A conical vessel of radius 6 centimeters and height 8 centimeters is completely filled with water. It's full of water. A sphere is lowered. So you're putting a sphere, you're not throwing it, then the water will splash out. You cannot accurately find out how much water has come out of the vessel. So you slowly lower, meaning you slowly introduce the sphere into the conical vessel. So the amount of water that overflows will be exactly equal to the volume of the sphere because you're doing it very gently. So no extra water is going to come out. The volume of the water that will flow, that will overflow, will be exactly equal to the volume of the sphere. The sphere has taken space inside the vessel. So proportionate to that, equal to that, the volume of the water will flow out. Equal to that, the water which flows out, the volume of the water that flows out will be equal to the volume of the sphere that has been immersed. So a sphere is lowered into the water and its size is such that the size of the sphere is such that when it touches the sides, it is just immersed. What fraction of the water overflows is the question. Okay, so see, the figure is like this. Conical vessel, you can see the sphere here. And see, it just touches the sides here. It touches the sides here, here, and here. Can you see that? The sphere, you should not draw the sphere here like this. Because then this one is not touching the base of the cone. It just touches the sides of the cone. The curved surface and the the flat circle of the cone. See, you cannot draw the sphere here because then the sphere touches this part and this part of the cone, but it doesn't touch the top part of the cone, right? But it's given that when it's lowered into the water, its size is such that, sorry, a sphere is lowered into the water and its size is such that when it touches the sides, it's just immersed. It touches the sides, it's just immersed. So like this. So you can see that the sphere touches the base of the cone and the sides of the cone. And so the size is like this and it's just immersed. So meaning it's not popping out of the cone. The sphere is not popping out of the cone. It's not popping out of the cone like this, nor is it completely inside the cone. Nor is it completely inside the cone like this. You understand? That's what it is when the question says it is just immersed. It's just immersed. Okay. Now, how do we, from where to start is equal? Okay, we understand the question. Now, how to start the answer? Like, what is it first thing which I should find? Right? Okay. So now the two solids here are cone and sphere. Now, for the cone, we have the radius and the height. And if you want, you can find the slant height using the relation L square is equal to h square plus r square. So for the cone, you don't have to find any value. Like you know the radius, you know the height, you can find the slant height. Okay, now talking about the sphere. Do we know the radius of the sphere? No, we do not know the radius of the sphere. But is that the question? No, that's not the question. The question is not to find the radius of the sphere. The question is to find the fraction of the water that overflows. And to answer this question, you need to have all the values of the cone and the sphere. So for cone we have, for the sphere, we just need the radius. That's enough. For the sphere, we just need the radius, but we don't have the radius. So the first step is to find the radius of the sphere. The first step is to find the radius of the sphere. All right. Now we have used a theorem here, which you will be seeing in the chapter circles. Okay. We have used a theorem here to show that certain angles are 90 degrees. To show that certain angles are 90 degrees, we have used a theorem. It's a very simple theorem. So you will learn this in the chapter. You will see the proof in the chapter circles. All right. Okay. And the theorem is circle, tangent, point of contact. Through the point of contact, if you draw the radius and the tangent at the point of contact are perpendicular to each other. Circle, tangent, where the tangent touches the circle is called the point of contact. There will be only one point common between the circle and the tangent. There are many points on the circle. There are many points on the tangent. The tangent is a line. There are many points on the line, the tangent line. There are many points on the circle. There are many points on the tangent. But there'll be only one point common between the circle and the tangent. Okay, what's a tangent? You know what a tangent is. We've seen this in standard 9. A line that touches a circle at exactly one point. A line that touches the circle at exactly one point is a tangent to the circle. Okay. So this point where the tangent touches the circle is called the point of contact. And if you take the radius through the point of contact, now this radius and this tangent here will make an angle of 90 degrees. The tangent and the radius through the point of contact are perpendicular to each other. The tangent and the radius which is drawn through the point of contact are perpendicular to each other. Am I clear? Okay. So now you can see this is the sphere. This is the center of the sphere. We call it O. This is the center of the sphere. We call it O. And from here, draw the radius. Draw any, actually see, you can draw any radius. See, this is a radius. This is a radius. This is the radius. Anything, all these are radii. You choose to draw the radius connecting the center and the point of contact. So you can see this acts as a tangent to the sphere. This line or this line segment acts as a tangent to the sphere, right? So this is the point of contact. E is the point of contact and O is the center. So you join OE. Why we are joining OE? Because E is the point of contact. O is the center of the circle. So when you join OE, it is a radius and it is a radius through the point of contact. See, from the center of the sphere, you can show many radii like this, many radii. I'm telling you why we are taking OE. That's what I'm explaining. So I've taken this point E, which is the point of contact, wherein AC is the tangent. AC is the tangent, E is the point of contact. Through the point of contact E, we take the radius EO, so that we can use the theorem that says the tangent and the radius through the point of contact are perpendicular to each other. So it's 90 degrees here, correct? Now this is 90 because it's a right circular cone. So the height and the radius are perpendicular to each other. It's a right circular cone. The cone we are talking about is a right circular cone. So the height of the cone and the radius of the cone, they are perpendicular to each other. That's why it is a right circular cone. The height of the cone and the radius of the cone will be perpendicular to each other. So that's not theorem. That's because it's a right circular cone. So we have 90 degrees here. All right. And we have 90 degrees here by the theorem. Okay, let me talk about the other labels in this figure. So, okay, so the other labels. So like this it is. I've marked A. Okay, I've marked B here. I've marked C here. Then I've taken the perpendicular height. Okay, and then the radius. So it's like this. Till here is okay. Then the sphere. Correct? Correct? Then I've taken the point of contact. I've called that E. Okay. Then the center of the sphere O. All right. Then I join OE. That's it. These are the markings you see here. These are the markings you see. A, B, C, D. O is the center of the sphere. E is the point of contact because AC acts as a tangent. E is the point of contact. And EO is the radius through the point of contact. So we use a theorem which says that the tangent and the radius through the point of contact are perpendicular to each other. So we have 90 here. So now we have two right triangles. We have two right triangles. So the one right triangle is ADC and the other one is AOE. Correct? ADC is a right angled at D. And AOE is also a right angled at E. Now for these two right triangles, there is a common angle. There is a common angle A, this one. A meaning DAC. For the big triangle, it is DAC, this one, DAC. And for the small triangle, the same angle is called OAE. The same angle is called OAE for the small triangle. Correct? We have one right triangle ADC and another right triangle AOE. Okay. Now these two right triangles have a common angle. This is the common angle. Now this common angle is called DAC for this triangle. And the same angle is called OAE or EAO for this small triangle. Correct? Now, see, we understood that we have to find the value of R. Once you find R, the answer to the question is very simple. We just have to find the value of R, and that's what we're doing now. Okay, so now use a trigonometric ratio in these two triangles. Now, you'll ask me, like, why you're using tan? You use sine, you use cos. When you use a trigonometric ratio, you should be able to find something, right? So you try to use sine in both the triangles. You try to use cos in both. Well, I'll do it. Okay, I'll do it. I'll just explain what is here. So I've used tan. I found tan of this angle in both the triangles. I found tan of this angle in both the triangles. Okay, you can use, if sine cos works, you can use any of it. You can use sine, cos, tan, cosecant, secant, cot. Nothing like you should use tan only. If sine doesn't work, then try cos. If that doesn't work, then try tan. So it's like that. See, when we say it doesn't work, that means when you don't have sufficient information to use sine, then we cannot get an answer using that. So we use cos. That's what I meant. Okay. So now find tan of this angle. So see here, in right triangle AOE, the small triangle, tan of OAE, tan of this angle is equal to opposite by adjacent. Which is the side opposite of this angle? OE, this one. Remember, this is the hypotenuse. This is the hypotenuse because it's opposite of the right angle. This is the hypotenuse. So opposite by adjacent. This is the opposite side. This is the adjacent side. Correct? Now, before that, I should have told you this. There's also a theorem from the same chapter which says that tangents from an external point to the circle are equal in length. Tangents from an external point to the circle are equal in length. You have a circle. Okay, there's a point here. Now, you can draw two tangents to the circle like this. What is a tangent? A tangent is a line that touches the circle at exactly one point. So see, this will go on. It's a line. It goes on. You can even produce it like this. Okay. A tangent is a line that touches a circle at exactly one point. Now, circle, external point. So from this external point, you can draw two tangents to the circle. See, they're lines, okay, like this. Now, this one is called a tangent segment, which is a tangent segment from here to here is called a tangent segment. Like line segment. Line segment. What's a line segment? A portion of a line. A line segment is a portion of a line. Line segment, like that tangent segment, is a part of the tangent. Which part of the tangent? Between that external point and the point of contact. Which is the external point? This is the external point. Which is the point of contact? This one. So this piece is called a tangent segment. Now, for the other tangent, this is the point of contact. The same as the external point. And this also is a tangent segment. Now, these two are equal in length because they're from the same external point. Tangents from the same external point to the circle are equal in length. Tangents from the same external point to the circle are equal in length. So now can you see this point C as an external point to the circle? So CD is equal to CE. CD is equal to CE. Look at C as the external point. Look at C as the external point. And if you look at C as the external point, CB is a tangent with D as the point of contact. CA is a tangent with E as the point of contact. So CD is equal to CE. Tangents from the same external point C to the circle are equal in length. C is the external point. And from C, this is the tangent. CB is a tangent. And from the same point C, CA is a tangent. But CB is equal to CA. No, not that. The tangent segments are equal. Which one? The tangent segments are between the external point and the point of contact. This is the point of contact. This is the external point. So this length is equal to this length because external point, point of contact. So CD is equal to CE, correct? Okay. Now it's given that the radius is 6. The radius is 6. So this one is also 6. And by Pythagoras theorem, using that relation L square is equal to h square plus r square, we know that this is 10 because the radius is 6. The height is 8. So the slant height is 10 by Pythagoras theorem, right? So if this is 6 by the theorem, but the whole thing, the slant height is 10. So 10 minus 6, this is 4. Correct? Renu? All right. So now OE is the radius, correct? And what about OD? That's also radius, no? Radius, that's also radius. OD is also radius. Okay. Now coming back, tan of this angle is opposite. This is the opposite side by adjacent. Adjacent is not this. This is the hypotenuse because this is a right angle. This is the adjacent side. So you can see here OE by AE. So what is OE? OE is R. OE is R by AE. How much is the AE? It's 4. It's 4. You understand that? R by 4. I explained that. OE is R. This one is R. And how much is AE? AE. Yeah, we understood. No, the whole thing is 10. Slant height is 10, but this one is 6. So the remaining part is 4. So R by 4. Next, find tan of the same angle in this big triangle ADC. Opposite by adjacent. Opposite is DC. Opposite DC and adjacent is AD. DC by AD. DC is 6, AD is 8, so 3 by 2. Now we have found tan of the same angle. See, these two angles, these two are equal, no? This one is equal to this one, right? Because it's the same angle. This is equal to this. Therefore, this is equal to this. See, like if x is equal to y and a is equal to, okay, x is equal to z. X is equal to y, x is equal to z. These two are the same, no? X, x. So that means y is equal to z. Similarly, tan of which angle? What is this one? This angle. And here tan of which angle? The same angle. The same angle. So this is equal to this. So this result r by 4 is equal to this result 3 by 2. So r by 4 is equal to 3 by 2. When you work this, you find the value of r. The radius of the sphere is 6 centimeters. Now find the fraction of water that overflows. So fraction of water that overflows will be, see, like if you're asked to find the fraction of girls in the class, how will you find the fraction of girls in the class? Number of girls by the total number of students in the class. How will you find the fraction of girls in the class? Number of girls by the total number of students in the class. So in the same way, fraction of water that overflows will be the volume of water that overflows by the total volume of water. Related. Fraction of water that overflows will be volume of water that overflows divided by total volume of water. Total volume of water, correct? How will you find the fraction of girls? Number of girls by the total number of students in the class. So how will you find the fraction of water? It will be the fraction of water that overflows will be volume of water that overflows by the total volume of water. What is the volume of water that overflows? It's equal to the volume of the sphere. And what's the total volume of water? It's the volume of the cone. Maybe you can, I'll just include this also. Just write this. Before this, you can write this one. Then how do you find the volume of the sphere? 4 by 3 pi r cube and cone 1 by 3 pi r square h. Yeah, substitute the values and this is the fraction of water that overflows. Yeah, write down, children. Please take down the question and write down the answer. I've written continued because the answer ends here. Continued is I have an alternate solution. For that, I've written continued. The answer ends here. This is the end of the answer. Please include this here. Angle OEA is equal to 90 degrees, correct? OEA is 90 degrees. Reason? Radius perpendicular to tangent. In short, I've written radius perpendicular to tangent. Just include that there. Done writing, online children?
Yes, ma'am.
Yes, ma'am.
Okay. Pushed? Yeah. And yeah. Yeah, I'll help you. Yes, ask me. Simply ask you. You're getting 3. You're getting 3. Okay. So what have I done? Okay. Let's see. So volume of the sphere. Okay. Here in the class, somebody has a doubt. So let's see that. Okay. So 4 by 3 pi r cubed is correct. Divided by 1 by 3 pi r squared h. Right. So 3 are cancelled. Then this pi and pi also gets cancelled. So now this 4 I've written here. And radius of the I've written 3, is it, instead of 6? Radius of the sphere is 6, right? I've substituted 3. Oh, okay. But I think I've written the correct answer. One second. Okay, I've gone wrong in substituting here. Let me do it again. 4 into, so 3 and 3 gets cancelled. So we have 4. Pi cancels in the numerator and denominator. R is 6. So 6 into 6 into 6 divided by r squared h. What is r squared? What is the r of the cone? 6. So 6 into 6 into h, height of the cone, which is 8, right? Okay, so 6 and 6 cancel. 6 and 6 cancels. And here it's going to be 4 ones are, 4 twos are, right? Okay. 2 ones are and 2 threes are. So it's 3. No, that means I've not calculated the 1 minute. R by 4 is equal to 3 by 4 here. By mistake, I've written 3 by 2. No, because I can't get 3 as the answer. The fraction that overflows cannot be 3. Okay. Anyways, thank you, Jai Varshini. Yeah. So here I've gone wrong. I'll just correct that. This part, while calculating, yeah, here 3 by 4, this is 6 by 8 is 3 by 4. So 3 by 4. So now here 4 and 4 will get cancelled. So R is 3. R is 3. So then the substitution is correct. I'm so sorry for the confusion. While typing, I've made a mistake here. All of you, please note. Online children, please look at your screen. 6 by 8 is 3 by 4. 6 by 8 is 3 by 4. So here 3 by 4. 4 and 4 gets cancelled. So the value of R is 3. The value of R is 3. All this is correct. Why nobody online or the others couldn't find out? Online children. Blindly copy it, whatever is on the screen. Calculations you must be doing by yourself. So 6 by 8 is 3 by 4. I've written 3 by 2. Nobody could make out that. Thanks, Jai Varshini, once again. All right. I hope all of you made the correction. Yeah, so you can try with sign also. See, I've worked it with sign. Same thing. I've used sign. So maybe I'll remind me. I'll give this as a test tomorrow. I'll ask you to work it using sign. We'll do it in the class tomorrow, meaning in the next class. You must remind me. So you can work it. See, I've used a different ratio here. R is 3. The rest of the working is the same. It's just that we are finding R, the value of the radius, using this trigonometric ratio sine in both the triangles. Okay. Same thing I've worked using the concept of similar triangles. But since we have not learned that chapter, we'll not do that now. When we do the revision, we'll come back to all this when we do the revision. So then we can see this method also. All right. So now the two new theorems from this chapter circles, which you have seen is tangents from an external point to the circle are equal. So here CD is equal to CE. CD is equal to CE. And then the radius and the tangent at the point of contact are perpendicular to each other. Yeah, this is your next question. Please take down the question and try it yourself. To find the height of the cone, please tell me the value. Found the height of the cone? Online children?
Ma'am, 42 centimeter.
Which sum? 42, is it?
Yes.
Okay.
Ma'am, I got 28 centimeter.
Yeah, even I'm getting the same. I'm getting H's 28. Asif has said 35. See if I'm right. H is 28. See, we just work using the information given here. It's given that the volume of the cones, if the radius of the base of the cone is 21 centimeters and its volume, that is the volume of the cone, and its volume meaning volume of cone. Radius of the cone is 21 centimeter and its volume, that means the volume of the cone, is 2/3 the volume of the hemisphere is given. Volume of cone is 2/3 the volume of hemisphere is given in the question. See it here. And its volume is the volume of the cone. The volume of the cone is 2/3 the volume of the hemisphere. So just write that. That's given to us, write that. Volume of cone is equal to 2/3 into volume of hemisphere. You want me to read that again? It's here. If the, sorry. if the radius of the base of the cone is 21 centimeters and its volume, whose volume? Cone's volume. So volume of cone is 2/3 the volume of the hemisphere. Write that and then substitute the relevant formula. Volume of cone is 1/3 pi r square h is equal to 2/3. So 2/3 into volume of hemisphere. What's the formula to find the volume of a hemisphere? 2/3 pi r cube. We're using the same r because radius is same for both the cone and the hemisphere. So I cancel 3 and 3 on both the sides, pi and pi on both the sides, and r square and r cube. So there is one r left here. Correct? R, we use the same r because it's the same for the cone and the hemisphere. So on this side, we have only h. H is equal to 2 into 2 into, there is one r. What's the value of r? 21. Divided by, there is 1 3 here. So 3. Now 3 1s are 3 7s are. So 7 4s are 28. So the height, now whose height is this? This is the height of the cone, not the height of the toy. See, this is h. From where are we getting this h? From the volume of cone. So this is the height of the cone. H is the height of the cone. Next, we have to find the surface area of the toy. So how do you find the surface area of the toy? Surface area of the toy is equal to CSA of cone plus CSA of hemisphere. But before that, you should find the slant height of the cone. You must find the slant height of the cone. So how do you find the slant height? L is equal to root of h square plus r square. H square plus r square. So that is square root of 28 square plus 21 square. Please work this, find the value of L, and then find the surface area of the top. CSA of the cone plus the CSA of the hemisphere. What's the value of L? Correct? And children, any questions? Yeah. Completed online, children?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay. Yeah, there's the next question. Yeah, please write down the question. Write yourself. Okay, so working with the condition given in the question, CSA of the hemisphere is equal to the CSA of the cone is given. CSA of hemisphere is equal to CSA of cone is given. So which means CSA of hemisphere 2 pi r square is equal to CSA of cone pi r L. So you can cancel out pi and pi on both the sides and this r and this r here. So one r will remain. Correct? So 2r is equal to L. After cancelling out pi r on both the sides, pi r on both the sides, we'll have 2r is equal to L. That means the slant height is equal to twice the radius. Slant height is of the cone is equal to twice the radius. We have to find the ratio of the radius to the height of the conical part. So we'll find now radius is r. To find the ratio, you should find the height also in terms of r. You need to find the ratio radius by height. If radius is r and height is h, how will you find the how will you find the ratio? You need to find the ratio radius by height. Radius is r, height is h. How will you find the ratio? So you must have, see, here you have slant height in terms of 2r, right? We have slant height is equal to 2r. That is, we have the slant height in terms of r. And r is r. So we are now trying to find h in terms of r. Radius is r. Slant height is 2r. So now we are going to find h in terms of r. So then you can find the ratio r by h. What is the radius? R. What's the slant height? 2r. So using that relation h square, L square is equal to h square plus r square, we'll find h also in terms of radius. So write this, L square is equal to h square plus r square. What is L? 2r. So 2r the whole square is equal to h square plus r square. So you find that h square is equal to 3r square. H is equal to square root of 3r square. So h is equal to root 3r. So we have found the height in terms of r. We found height in terms of r. So now the required ratio is radius by height. Radius is r. Now height is root 3r. So r and r gets cancelled. The ratio, the required ratio is 1 by root 3. We've taken the radius as r. And we have also got L is equal to 2 into r. So now we are finding h in terms of r using this relation. So what is h? Root 3r. Now it's easy to find the ratio. Radius is r by h is root 3r. So the ratio is 1 by root 3. Yeah, please write down. I'll just wait for some time. Finished? Online children, done writing?
Yes, ma'am.
Yes, ma'am.
This is the next question. Please take down the question. This is the next one. Okay. I think we have to see the concept of similar triangles in, in brief to answer this question. Now, we know what is meant by congruent triangles. Okay, so two triangles are said to be congruent if their corresponding angles are equal and their corresponding sides are also equal. So two triangles are congruent if one triangle is an exact copy of the other. Two triangles are said to be congruent if one triangle is an exact copy of the other one. So when two triangles are congruent, their corresponding angles are equal, their corresponding sides are also equal. Now, when do we say that two triangles are similar? In two similar triangles, the corresponding angles will be equal, but their corresponding sides are proportional. Proportional. We'll just understand it quickly. So supposing you have any triangle actually. Supposing you have a triangle like this. Say the sides are some 6, 7, and 10. Right. Now, if you look at this triangle under a magnifying glass, it looks bigger, right? The sides will look proportionately bigger. I'm just trying to make you understand what is meant by similar triangles. Now you have this triangle with you of sides 6, 7, and 10. Now you view this triangle under a magnifying glass. So the sides are proportionately larger. Correct? The sides will look proportionately larger. Yes or no? 6 centimeter will not look like 6. It may look like 12. 7 centimeters may not look like 7 centimeters. Under magnifying glass, it might look like 14. And 10 will be like 20. You'll see a bigger triangle. Now this triangle which you have and the triangle which you see under the magnifying glass are similar triangles. Because they are not identical. But the triangle you see under the magnifying glass is proportionately larger. Proportionately larger. Meaning, in this example, all the sides are doubled. In the triangle you see under the magnifying glass, all the sides are doubled, proportionately larger. But when the triangle looks like that, the angles will be the same. The angles will not be doubled. Then the angle sum property will go out of order. Angles will not be doubled. Angles will be the same. See, you can, if you feel why the angles don't get doubled, you can just tell yourself this one. Supposing this is a small equilateral triangle. Okay, say like sides 1 centimeter, 1 centimeter, 1 centimeter. Small. What a small equilateral triangle, 1 centimeter, 1 centimeter, 1 centimeter. So what will be the measure of each angle of this equilateral triangle? 60 degrees. Now imagine a big equilateral triangle of side 1000 centimeters. Big equilateral triangle of side 1000 centimeters. There also the angles will be 60, 60, 60 only. So whether it is a small equilateral triangle or a very large equilateral triangle, each angle of that triangle will measure 60 degrees. All right. So in the same way here, when two triangles are similar, if the sides are doubled, if the sides of one triangle are double the sides of the other triangle, the angles need not be doubled. The angles will be the same. The sides are doubled. So this is what, this is when we say that the triangles are similar. In similar triangles, the corresponding angles are equal and the corresponding sides are proportional. The corresponding sides will be proportionately larger or proportionately smaller. Proportionately larger or proportionately smaller. Now, proportionately smaller meaning divide every side by 2. If you diminish the size, of this triangle, okay, you don't look at this triangle under a magnifying glass. You diminish the size of this triangle. Okay. So 6, you diminish it. 3, 7, 3.5, 10, 5. So you reduce, you divide by 2. So you get a smaller triangle. So the sides of this triangle are proportionately smaller than the sides of this triangle, right? But the angles will still be the same. The corresponding angles will be equal. The corresponding angles will be equal. So two triangles are said to be similar if their corresponding angles are equal and their corresponding sides are proportional. So when we talk about two similar triangles, one triangle may be small, the other very large. They need not have the same size, like in the case of congruent triangles. In congruent triangles, the two triangles are exact copies of each other. But in similar triangles, one triangle is small, the other is proportionately large. Or one triangle is large and the other triangle is proportionately smaller. So in these two triangles, you will see that the corresponding angles will be equal and the sides are proportional. If you have the sides of one triangle, if you multiply the sides, say by some 2.3, you will get the sides of the other triangle. Or you divide the sides by some value, you will get the sides of the other triangle. You multiply the sides or you divide the sides by some number, you will get the sides of the other triangle. Now, like we have, congruence criteria, we also have similarity criteria. So how do we prove the two triangles are congruent? We have 5 rules, right? So you can show that two triangles are congruent using the SSS congruence criterion, SAS congruence criterion, ASA congruence criterion, AAS congruence criterion, RHS congruence criterion. So these are the 5 congruence criteria we have. Criterion is singular. This is singular. Criterion. Criteria is plural. This is plural. This is singular. Okay, so we have 5 congruence criteria. So this is a congruence criterion, criterion. So these are the 5 congruence criteria. Similarly, we have a similarity criteria. We'll only see now for this answer. I'll just tell you about the AA, also called the AAA. AA or the AAA similarity criterion. So this is used to show that two triangles are similar. This one is used to show. So why do you use SSS? To show that the two triangles are congruent. Why do you use the RHS rule? To show that the two triangles are congruent. In the same way, we have something called the AA. You can say AA, or if you write 3 is AAA. The AA or AAA similarity criterion. Using this, you can show that two triangles are similar. Now, when we show that two triangles are congruent, then we write some results. No, we say because the triangles are congruent, their corresponding parts are equal. CPCT, remember? Corresponding parts of congruent triangles are also congruent. Once you show that two triangles are congruent, their corresponding parts, that is the corresponding angles and the corresponding sides are equal. In the same way, when you show that two triangles are similar, their corresponding sides will be proportional. Corresponding angles are equal. Their corresponding sides will be proportional. All right, now AAA is a similarity criterion. Okay. Keep all this in mind and look at this one. I'll read the question for you. A cone of radius 10 centimeters. Okay, that's the whole cone. Is divided into 2 parts by drawing a plane through the midpoint of its axis. So midpoint of the axis meaning this is the height of the cone. This is the midpoint of the height. So like this is the plane going through the midpoint of the axis. Axis is the perpendicular height of the cone. Axis is the perpendicular height of the cone. So through the midpoint of the axis, there's a plane which cuts the cone into 2 parts. There's only one cone. There is one cone. This is the cone in the question. This is the cone. This is the perpendicular height of the cone, which is called the axis of the cone. This is the midpoint of the axis. Through this midpoint, there is a plane, a cutting plane. Now, this plane goes through the midpoint of the axis. So it cuts the cone into two parts. There's one part here, there's one part here. It cuts the cone into two parts. You will have to compare this plane is parallel to the base. It doesn't go like this. See that plane, you know. 1 minute. This is the midpoint of the axis, right? The plane does not go like this. The plane goes parallel to the base. It goes parallel to the base. You don't, the plane does not go through the midpoint like this. The cutting plane is parallel to the base of the cone. Do we understand the difference? The cutting plane. This is the midpoint of the axis. The cutting plane, it doesn't go like this. It doesn't cut the cone like this. It doesn't cut the cone like this. The cutting plane is parallel to the base. It's parallel to the base, so it goes like this. The cutting plane is parallel to the base of the cone. So these are the two parts. You need to compare the volumes of the two parts. Compare the volumes of the two parts. Got that? Okay. So I'll just leave you till here, after which you can try to understand and then I'll explain it for you. So this is the whole cone. AC. AC is the axis of the cone. CD is the radius. B is the midpoint of the axis. And this one is the plane through the midpoint, the cutting plane through the midpoint. And it's parallel to the base. All right. Okay. So I've just marked these angles. This is 90 degrees. This is 90 degrees. Why this is 90? Because this is parallel, you know, this is parallel to the base. And you know, this is 90 because right circular cone. So you can say corresponding angles are equal because these two lines are parallel. These two lines are parallel, so corresponding angles are equal. So this also is 90. Okay. So now in these two right triangles, in this right triangle and in this right triangle, that is in right triangle ABE and right triangle ACD. This small right triangle, this one, ABE. And in this whole right triangle ACD. Okay. We're using the AA similarity criterion. Angle 1 is common to both the triangles, correct? Angle 1 is common to both the triangles. Yes or no? Yeah. And then angle 2 is equal to angle 3, 90 degrees. So we have shown two pairs of equal angles in the two triangles. That's what is AA similarity criterion. If you can show two pairs of equal angles in the two triangles, the triangles are similar. If you can show that two pairs, one pair, two pairs. If you can show two pairs of equal angles in the two triangles, then the two triangles are similar by the AA similarity criterion. So angle 1 is common to both the triangles, and then angle 2 of the small triangle is equal to angle 3 of the big triangle because each of it is equal to 90 degrees. So by the AA similarity criterion, the two triangles are similar. Now, once a triangle is similar, their corresponding sides are proportional. Their corresponding sides are proportional. Now, when you show the two triangles are congruent, you will have to write their names in a specific order, correct? When you show the two triangles are congruent, 9th standard, you have to name the triangles in a particular order. Like if you name the first triangle ABC, the second one should rhyme with ABC. Right? Same thing here also. So how do you name it? in the correct order. If you call the first triangle ABE, match the corresponding parts. Angle A of the small triangle is equal to angle A of the big triangle. Angle B of the small triangle is equal to angle C of the big triangle. And then the third vertex D. This is the correct order. If you write BAE, then you must write CAD. Change it accordingly. So the order in which you write the vertices of the two triangles is very important. The order in which you name the two triangles is very important. I'll come again. If you call the small triangle, say BAE, supposing you call it BAE. In the small triangle, B is 90 degrees. So in the big triangle, C is 90 degrees. In the small triangle, A, that's the common angle. So in the big triangle, also it is A only. Then write the third vertex of the big triangle, CAD. Am I clear? So you must name the triangles in the correct order. So triangle ABE, I've written ABE. A is the common angle, then B 90 degrees, and then the third vertex C, ABE. In the same way, you should name this. A is the common angle, C is 90 degrees, and D is the third vertex. So these two triangles are similar by the AA similarity criterion. Once a triangle is similar, the corresponding sides, their corresponding sides are proportional. Now, how do you write the proportion? Very easy. Once you name the triangles in the correct order, writing the proportion is very easy. AB by AC is equal to BE by CD is equal to AE by AD. Now you'll say why you have not written AE by AD. You can write. Then you won't solve. Because AE and AD, they are a part of the slant heights. AE and AD, slant heights. But we have to compare the volumes of the two parts. For volume formula, you don't get slant height. Only for area, you get slant height, right? When we talk about cones, when do we get L? Only in area, curved surface area, total surface area, pi RL, pi R into R plus L, only for curved and total surface area. For volume, we don't have L, no? Here we have to compare the volumes of the two parts. So I've not written the segments, which pertain to the slant height. AE by AD I've not written because they're of the slant height. Okay. Do we understand this order? So how do you write the proportion? Proportion is AB by AC is equal to BE by CD. I have not written AE by AD because AE is a slant height of the small cone and AD is a slant height of the big cone. But we have to compare the volumes where we don't need L. So we have not written. So now what is AB? AB I've called it as H. AB I've called it H. See the whole thing, this is the midpoint, right? So if this one is H, this is also H. This one, no? Yeah. So AB is H, this one is H. AC is 2H because this is the midpoint. This is also H. H plus H, 2H. So are we following this? H and 2H. Is B the midpoint of AC? Is B the midpoint of AC? Yes, because the cutting plane goes through the midpoint of the axis and it's also parallel to the base. So B is the midpoint of AC. We have called AB as H. So BC is also H. So AC is 2H. BE is radius of the small cone and CD is the radius of the big cone. So I've written R by R. So H and H will get cancelled. We know that the radius of the cone, the big cone, is 10 centimeters. The radius of the big cone is 10 centimeters. So 1 by 2. 1 by 2 is equal to R by 10. This R is 10 centimeters. This one is 10 centimeters. Because it's given here. Radius is 10. So substitute R10. So when you cross multiply and work this, you get R is equal to 5 centimeters. What is 5? The radius of the small cone. The radius of the small cone is 5 centimeters. Is that understood? So see, we can use trigonometry similar. In the first question of today's class, we use trigonometry to find the radius of the sphere. We had two right triangles. There also we can use similar triangles. I told you, I thought there'll be no other question based on similar triangles. I said we'll not do that. We'll do it once, meaning during revision, I think I mentioned. Yeah, but now you now know how to show the two triangles are similar. So in the first question of today's class, we used trigonometry to find the radius of the sphere. How did we use trigonometry? We took up two right triangles and we identified the common angle there. And we used the same ratio for that common angle. We found tan of the same angle in both the right triangles. We found tan of that angle, that common angle in both the right triangles. We got some results and we equated them to find the radius of the sphere. So you can use trigonometry to find missing values. So here we have used similar triangles, the concept of similar triangles to find the radius of the small cone. The radius of the whole cone is 10 centimeters. We don't know the radius of the small cone. And how did we find that? Using this proportion. But how did we get that proportion? Because we showed the two triangles similar. And how did we show that they are similar? Using the AA similarity criterion. Yeah. Please work. The remaining part, this one is called the frustum of a cone. You can just remember that term. Frustum is not there in your syllabus. But this question is not based on a frustum. So such questions you can get. The remaining part, see now when you have a whole cone like this, when a cone runs parallel to the base and the top portion is removed. The top is a small cone, right? If you remove the small cone, the remaining portion is called the frustum of the cone. From a whole cone, if a plane cuts through the cone and say the plane is parallel to the base, in our case, it will mostly be parallel to the base. So if this cutting plane, which goes parallel to the base, cuts the cone into two pieces. The top one is a small cone. This bottom portion is called the frustum of the cone. Frustum means the remaining portion. So here I've written volume of small cone, which is this one, by the volume of the frustum. Frustum is this remaining portion, this one. You'll have to compare the volumes of the two parts. Which are the two parts? The two parts are this one and this one. This one is the small cone and this one is the frustum. So you'll have to compare the volumes of the two parts. Yeah, do it. I will explain this. You can help yourself first and then we'll discuss. because you worked this using similar triangle, I've explained that. We can also use it using, we can also work this using trigonometry. I'll also do that for you. Okay. So to compare the volumes of the two parts, it is the volume of the small cone by the volume of the frustum. What will be the volume of the small cone? 1/3 pi r square h. small r square, small h. And volume of the frustum, it's the volume of the whole cone minus the volume of the small cone. Volume of the frustum will be volume of the full cone minus the volume of the small cone. So what's the volume of the full cone? Same formula, 1 by 3 pi r square h, but substitute the values carefully. So 1 by 3 pi r square, this r square into h. What is h? 2h. What's the volume of the whole cone? Formula is 1 by 3 pi r square h, but r is capital R and h is 2h. So 1 by 3 pi r square, capital R square into 2h. This is the volume of the full cone minus the volume of the small cone. Minus the volume of the small cone. Okay, what's the volume of the small cone? This one. This is the volume of the small cone. So that will be the volume of the remaining portion, the frustum. The volume of the whole cone minus the volume of the small cone is the volume of the frustum. Now, take out common. You can't cancel this and this because there's a minus here. See, supposing you have x by, say like y minus x. You can't cancel x and x. Can't cancel x and x. So you cannot cancel 1 by 3 pi r square h and 1 by 3 pi r square h. No, you cannot cancel because it's a minus here. So take out common in the denominator, 1 by 3 pi and h. 1 by 3 pi h is common. So in the bracket you will have r, because 1 by 3 pi h is common. So in the bracket you will have r square into 2 minus 1 by 3 pi h is common. So we'll have minus r square. Whatever is common, don't write it. Write the remaining in the bracket. So now 1 by 3 pi, 1 by 3 pi, pi, h cancels. So we have r square. What is r? 5. So 5 into 5. Pi r square into 2. What's r? Capital R was already given in the question, 10. So 10 into 10 into 2. 10 into 10 into 2. Minus r square. That is 5 into 5. So it's 200 minus 25, 175, 1 by 7. So the ratio is 1 by 7. Compare the volumes of the two parts. The required ratio is 1 by 7 or 1:7. All right. Now, we can also find the value of r using trigonometry. So we have two right triangles here. We have two right triangles with this one as a common angle. Angle 1 is the angle common to both the right triangles. Okay. Now we will not write any ratio connecting the hypotenuse. We will not write that. We will not write any ratio connecting the hypotenuse because that we don't want. No, we have to compare the volumes. So we'll make use of a ratio that does not need the hypotenuse. So tan only, because sine is opposite by hypotenuse, cos is adjacent by hypotenuse, tan is opposite by adjacent. So we'll try tan. Why we don't want to connect the hypotenuse? Because hypotenuse is about slant height. And slant height we don't want because we are going to compare the volumes. Okay, so we'll use tan. What is tan of angle 1 in the small triangle? Opposite by adjacent. What is tan of angle 1 in the big triangle? Opposite by adjacent. So we have found tan of angle 1 only in both. So that means r by h is equal to r by 2h. So h and h will get cancelled. We know that the value of capital R is 10. So r is equal to 10 by 2. R is equal to 5. So you can also work like that. Now don't say this is easier. Why did you spend time like this? Because I had it already like this. I thought, okay, let me do it. So the missing values can be found like this When you have, see why right triangle? Because trigonometry, we are learning trigonometric ratios in right triangles, right? We'll always be applying trigonometric ratios in a right triangle. So that's why. So ABE is a right triangle, ACD is a right triangle. And in these two right triangles, the common angle is angle 1. So we'll find tan of angle 1 in both the triangles. So tan of angle 1 in both the triangles. So this one is equal to this one. So the results R by H will be equal to R by 2H. So when you equate, you will be able to find the value. This part is the same. Okay, so I'll work it here. Please make a note of this. I'll work it here. So instead of similar triangles, you can also do it like this. Correct? Done all of you? Completed writing, online children?
Yes, ma'am.
Clear. Yeah, this is your next question. I think we have got this one, right? 2/5 of the water flows. No, I think we have got long time something. We'll do this one. Forget that. I think we have worked that question. Yeah. Try this question. I think your notebook is thick. Just give me a notebook, no? Akshada. Just one. Okay, so this is the cuboid in the question, okay? A cone of maximum volume, a cone of maximum volume is carved out of a block of wood of size 20 by 10 by 10. Find the volume of the cone carved out correct to 1 decimal place. So this is that block of wood, 20 centimeters. The dimensions don't match this, but okay, so 20 centimeters is the length, 10 centimeters is the breadth, and 10 centimeters is the height. This wood here, length 20 centimeters, breadth 10 centimeters, height 10 centimeters. Now, how can you remove the cone? So maybe you can use, when you're removing the cone, you will be using the opposite faces. Opposite faces. When you're removing a cone, you know, I'll tell you what I mean by that. You'll be using the opposite faces. Opposite faces meaning, see, like if the top of the cone, if the apex of the cone comes from here, the base of the cone will come out like this. So you'll remove like this. If the top of the cone, apex of the cone is here, then where will be the base of the cone? It will be here. So you'll pull it like this. You will be using the opposite faces of the wood. If the apex of the cone is here, then the base of the cone will be here, because the cone will be like this. If the apex of the cone is here, then the base of the cone will be from this side. If the apex of the cone is from here, then the base will come from the opposite side here. The circle will come from the opposite side. The opposite faces of the block will contain the apex of the cone and the base of the cone. Apex is that fine dot, and the base of the cone is a circle. If that fine dot, the tip of the cone is here, then where is the base of the cone? On the opposite base, here it will be. You'll pull it like this. If the apex of the cone is here, then the circular portion, the base of the cone will be here. If the apex is here, the base will be here. So you should write out the dimensions and see which one, so you can do it in 3 different ways. You can use these 2 opposite faces and bring out a cone, the biggest cone. You can use the top and the bottom face to bring out the biggest cone, or you can use these side faces to bring out the biggest cone, or you can use the front and the back face. Not to bring out the biggest cone, to bring out the cone. So which one will produce the biggest cone? We have to decide based on the dimensions you get. Based on the values of R and H you get. So we'll write that now, see. So this is what 20 is the length, 10 is the breadth, 10 is the height, okay? So we'll write all the 3 cases, case 1, case 2, case 3, we'll write all the 3 cases. Okay, case 1 is from like this, we're using the top and the bottom. Now, what is the bottom? What are the dimensions of the bottom? 20 by 10. See, you should, I'll not repeat this. Bottom, we are using the top and the bottom. Okay, where is the apex of the cone? Here. The apex can be here also. Both are the same. That will not change. Apex can be here, the base can be here, or the apex can be here and the base can be here. That's okay. So now we are using the top and the bottom faces. The apex is here. The circle of the cone is here. What are the dimensions of the base? 20 by 10. 20 by 10. Keep that in mind. 20 by 10. It's a rectangle. 20 by 10. 20 by 10. So the biggest circle you can draw will have diameter 10, not diameter 20. The biggest circle you can draw in this rectangle can have diameter 10, not diameter 20. You cannot draw a circle of diameter 20 here. You cannot draw a circle like this. You can't say, okay, let me draw like this. This is not a circle. That is an oval. The biggest circle you can draw in a rectangle of dimensions 20 by 10 is a circle of diameter 10. Yes or no? So the base is a rectangle of dimensions 20 by 10. Now, if the circle of the cone has to come out from here, the biggest circle will have diameter 10, not 20, 10. So what's the radius? 5. And what's the height of the cone? The cone is like this, no? So the height is 10 because 20 by 10 by 10, what's the height here? 10. The height is 10. So the cone will come out like this, no? The cone is coming out like this. So the height of the cone will be 10. We have to write out the radius and the height of the cone. For radius, we must see from which, a flat surface the base is coming out from. So when the apex is here, the base is here. If the base is here, dimensions are 20 by 10. So the circle can have maximum diameter 10, which means radius is 5. So radius we got. Now height. So the cone is coming out like this. So this is the height of the cone, which is 10. So in case 1, the diameter is 10, radius is 5, and the height of the cone is 10. Okay. In case 2, now supposing you're using the front and the back. Using the front and the back. From the front, you're getting the apex. Back, you're getting the circle. What are the dimensions of the back? The dimensions of the back. Okay, I'll show this only as the back. Okay, let's say the apex is from here and the circle is from here so that even the online children can see. The apex, we're using the front and the back face, the front face and the back face. From the back face, we're getting the apex, and from the front face, we're getting the circle. Now, front face dimensions 20 by 10. Correct? Front face dimensions 20 and height is 10. It's a rectangle. No, this one is a rectangle. What are the dimensions? 20 by 10. 20 by 10. So what will be the diameter? 10. The circle is coming out through this. So what's the diameter? 10. Radius is 5. And how is the rectangle coming out? From here, the circle, from here, the apex. So it's coming out like this, no? It's coming out like this. So this is the height. This will be the height. This will be the height. What's the height? From here, the apex, from here, the circle. So you're pulling a cone like this. We got the radius 5. So what's the height? 10. The height is 10. Case 3, you're using this as these two faces, that is the side faces. From this face, apex, from this face, base. Okay, apex from here, base from here. You're pulling out like this. You can pull out only in 3 different ways. Top, bottom face you can pull out, or front and back you can pull it out, or side you can pull out a cone. So this is now the sides we're using. Okay, so what are the dimensions of this side? What are the dimensions of this side? This is 10. And what's the height? 10. So the book looks like this. See the dimensions in the question. 10 by 10 it is. See the dimensions in the question. 10 by 10. Breadth is 10, height is 10. 10 by 10. So what will be the diameter? 10. So what's the radius? 5. See the side face here, dimensions 20 by 10 by 10. So the breadth is 10. The height is also 10. So in 10 by 10 is a square. So the maximum diameter is 10. Radius is 5. So from here you're getting the circle. So from here the apex, you're pulling it like this. So what will be the height of the cone? 20. The height of the cone will be 20 because the length is 20. The dimension that is not used will become the height, children. Now what are the dimensions we used here? 10 by 10, no? So what's the other one? 20. That will become the height. So the height is 20. So where are you getting the the maximum cone? Everywhere the radius is 5. But where is the height maximum? Here. So this volume is what you have to find. A cone of maximum volume is carved out of a block of wood of size 20 by 10 by 10. Find the volume of the cone carved out correct to 1 decimal place. Everywhere the radius is 5. But in the third case, the height is 20. So 1 by 3 pi r square h. 1 by 3 into 22 by 7 into 5 into 5 into 20. It's the answer. It's very easy. First time when we do, we are taking a long time. Then when you repeat, when you practice this, when you again, recall this procedure, it will become easy. You will not take this long to understand. You can use some other block, a thick notebook and understand again at your home by yourself. Let's do it again. I usually carry R.D. Sharma or R.S. Agarwal to the class when I used to write on the board and teach. So I used to hold that book. It was easier to teach. Now this time, online students, you were able to see what I demonstrated. Yes, no?
Yes, ma'am.
Okay. Let's see it quickly again. This is 20, length is 20, breadth is 10. Height is also 10. Don't get confused with this notebook. This notebook height is not, this is 10, this also is 10. Don't get confused. Length is 20, breadth is 20, height is also, oh, sorry. Length is 20, breadth is 10, height is also 10. Now, in how many ways can you pull out a cone? In 3 ways. You can use the top and bottom and pull it out. You can use the front and back and pull it out. You can use this side and pull it out like this. Okay. Okay, now if you're using the top and the bottom, using the top and bottom, using this and this will become the height. This will become the height. What will be the height? 10. Height is 10. If you're using, if the apex is from here and the circle is from here, then you're pulling it like this. So this is the height of the cone, which is 10. So let's write height 10. And the circle will come out from this rectangle, right? What are the dimensions of this rectangle? 20 by 10. 20 by 10, but circle drawn in this rectangle can have maximum diameter 10 only. So what's the radius? 5. Radius is 5. Case 2 is, we finished top bottom. Now we'll do front back. Front and back. So what will be the height of the cone? You're pulling it like this, like you're pulling the cone like this. So this is the height of the cone. This is the height of the cone. Because you're pulling the cone like this. So this will be the height of the cone. What's the height? 10. Height is 10. And from where are you getting the cone? From the front and the back face. Front and the back face. So what are the dimensions of the front face here? 20. 20 is the length and the height is 10. 20 by 10. Height is 10. 20 by 10. The rectangle here has dimensions 20 by 10. So radius is 5. Radius is 5 because 10 means maximum diameter is 10. So radius is 5. Because if you have a rectangle 20 by 10, you can draw a circle like this. That's all. Of diameter 10. So the radius is 5. Case 3 is you're using the side faces, using this side and this side. So the cone will come out like this. You're pulling it like this, or you're pulling out the cone like this. So this is the height. This becomes the height of the cone. So the height of the cone is 20. The apex is here and the circle is here. Circle is here. So this rectangle, what are the dimensions? Breadth 10 and height 10. Breadth is 10 and the height is 10. So 10 by 10. Here the rectangle is 10 by 10. This side the rectangle is breadth 10 and height 10. 10 by 10 it is. So 10 by 10, diameter is 10, so radius is 5. So maximum, biggest cone of maximum value is here. Correct? That's what you should find. Yeah, please write down the question and finish the answer. Finish writing the question. Or written the question, all of you? Okay. What's the answer you got? Oh, so sorry. Oh my God. Finish writing? Done writing, online children?
Yes, ma'am.
Okay.
Yes, ma'am.
All right. Your online children, use the emoji, raise your hand. Asif, Anirudhan, Keshav, Swati, Roshni, Sabarna, Sadhna, Aragamai, Mritsa, Niveda, Anugraha, Srivatsan. What about Hari Pranab? Keshav? Okay. All right. All right, children, online children, that's it for today's session. You may leave the call. Thank you and good night. Yeah, if you're finished, children, thank you. Good night.
Thank you.